This course is a production of ITM Consulting. Visit us on the web at www.itmconsulting.org.
Before you start your course, here are a few tips. Go at your own pace. You can pause the course at any time. And if you'd like to see any part of the course again, just rewind it and view it as many times as you need.
Welcome to ITM's course on Pin and Paste Process. This course will be presented in a multi-part series. This is Part 1, Introduction to Pin and Paste Process. In Part 1 of this series, we'll just cover the basics. We'll answer the question, what is the pin and paste process? We'll talk about incentives, and we'll talk about solder joint specifications. So let's go ahead and start from the beginning and answer our first question. What is the pin and paste process? The pin and paste process refers to the use of solder reflow technology to solder through-hole and odd-form components. On PCBs with both the surface-mounted and through-hole components, the through-hole components are typically soldered after the surface-mount components. This is done either by hand or using a wave solder machine. The pin and paste process allows through-hole components to be soldered at the same time and using the same process as surface-mounted components. Let's take a look at an assembly process for a circuit board that has both through-hole and surface-mounted components. First, the circuit board is printed with solder paste in a stencil printer. Then it may pass through a dispenser. Then surface-mounted components are placed onto the circuit board with a pick-and-place machine. Then the whole assembly is placed into a reflow oven, where the solder paste is melted, and then the surface-mount components are soldered to the circuit board. After this process, through-hole components are usually put into the circuit board by hand. Then the entire assembly is placed in a wave solder machine, where the through-hole components are soldered to the circuit board. Then there may be some other components added after the wave solder process that may be soldered by hand. In the pin and paste process, through-hole components can be soldered in the same way as surface-mount components. The stencil printer applies solder paste to both through-hole and surface-mounted device locations. In this way, the entire circuit board will go through the reflow oven with both surface-mounted and through-hole components present. This can eliminate both the wave soldering and the hand soldering processes.
Just take a look at how much more efficient this line layout looks once the pin and paste process has been implemented. It may sound obvious to implement the pin and paste process, but there can be some challenges. For example, in the pin and paste process, through-hole components must pass through the reflow oven. The reflow process presents these components with some very high temperatures. Not all through-hole components can withstand these temperatures, so components must be chosen carefully and specifically for the reflow process. It can also be difficult to provide adequate solder paste for through-hole joints with the stencil printing process. We'll learn more about these challenges in later parts of our series.
Now let's look at a little history. The pin and paste process was developed in about 1985. As early as 1988, companies like Motorola's ISG in Massachusetts were building 100% of their surface mount technology products using pin and paste. They used absolutely no wave soldering and produced billions of reliable solder joints. Now, the pin and paste process is used worldwide by many manufacturers. The pin and paste process is also known by several other names, like intrusive reflow, or reflow on through-hole, solder paste on through-hole technology, or even alternative assembly and reflow technology. All of these names refer to the same process.
So let's summarize the incentives for switching to the pin and paste process. Of course, the biggest incentive is always cost savings. You can eliminate capital equipment like wave soldering machines, laser soldering machines, and basically any equipment associated with traditional methods of through-hole soldering. You can save on labor costs by eliminating hand soldering operations and labor associated with wave soldering. Costs can also be saved by reclaiming floor space used in the wave and hand soldering processes. Then, of course, there's the material savings by eliminating materials like solder bar, bulk fluxes, wave solder pallets, and hazardous materials like solder dross created in the wave soldering process. There are also other incentives that offer more indirect savings, like the ongoing transition of component technology from through-hole to SMT, the increasing cost of through-hole connections, and the reduction in heating operations. Every time a PCB is put through a heating cycle like wave solder, reflow, or hand soldering, there's a risk of damage to the board, so eliminating any of these heating operations is a big benefit. But perhaps the most important benefit is the ability to design PCBs with complex components on the bottom side. In traditional processes, most complex components can only be put on the top side of the PCB because they are not able to pass through the wave solder process on the underside. If you can eliminate the wave solder process, then PCBs can be designed with complex components on both top and bottom side. This makes it easier to design smaller PCBs for smaller electronic devices.
Of course, solder joints created through the pin and paste process will have to meet the same specifications as solder joints created by wave soldering or hand soldering, like 270-degree wetting on the solder destination side, 330-degree wetting on the solder source side, and 75% of barrel fill. This brings us to the end of part 1 on our course on pin and paste process. Let's take a look at what we've learned. The pin and paste process eliminates the need for wave soldering and other soldering processes by applying reflow technology to through-hole components. The pin and paste process dates back at least to 1985. Cost savings like capital equipment costs, materials costs, labor's costs, and floor space costs are among the benefits of the pin and paste process. Solder joints created using the pin and paste process need to meet the same specifications as solder joints created by wave or hand soldering.
Thanks for joining us for part 1 of our series on pin and paste process. Be sure to check back with us for the remainder of the series, where we'll cover more in-depth topics like stencil design and component selection.
This has been a production of ITM Consulting. For other educational products and to learn more about our consulting services, visit us on the web at www.itmconsulting.org.